Hello, and welcome back to Advancing Synapse. And yes, I know it's been a little while since we've done a Synapse one, and there's plenty that we can look into, so expect a few more over the next few weeks. And today is something I've been meaning to take a look at for a little while, called Hyperspace, which is an awesome name for an indexing system in Spark, which is a weird idea. So I'm going to take you through what it is, how it works, what it looks like, the general commands, and get you started on the path of using Hyperspace to index your data within Azure Synapse Analytics. So don't forget to like and subscribe if the video is useful, and otherwise let's have a talk about what that means. So, indexing and Spark. So they don't go together, that's not a thing. And it's always been an issue with Spark in that you don't have that nice kind of B tree to kind of say, I want to get to this record, and then you can go down a B tree, find the exact pointer to the record you're looking for, like you would in a SQL server. So generally, Spark's not good at things like single record lookups and all that kind of stuff. And there's been kind of several different approaches to try and get around that problem. Now, the main way people do it is through partitioning. So partitioning in Spark, you say, I want to organize my data into subfolders. So subfolders are labeled with attribute equals value, the Hive partitioning style. And so you can say, if I'm filtering my data set for this value, just look in folders that match that value, and I can ignore all the other data. Essentially, I'm doing partition elimination as a form of indexing. Now, if someone comes along and wants to query my data using a different search predicate than I've partitioned for, tough luck. They're going to have to do a full scan of all of my data, bring it onto the Spark cluster, filter it down in memory, and then start working. So essentially, it just means we have one indexing approach, and that's it. And obviously, people do kind of work around that. They say, why don't I have 4 copies of my data, each with a different partitioning strategy to cater for my 4 different sets of users? And that's overhead, that's redundancy, that's cost. Sure, you can do it, and it works around some limitations, but it's not exactly slick. It's not exactly a great way of working. So, limitations for how you currently do it in Spark. Databricks, in terms of the Delta file format, have come up with this thing called Z ordering, or Z ordering for you guys across the pond. That's when we're saying, take my data, reorganize how I'm actually storing my data within my data files to try and improve, to optimize for data skipping. So that's with the Delta format, I've got minimum and maximum values for my first 32 columns. So if I've Z-ordered by a certain column that someone queries by, I can go, well, it's not in any of those. So I can just eliminate those from my query. And it's kind of like a form of partitioning, but it's baked into how I store my data in disk. And for anyone coming from the SQL Server background, that should hopefully sound a bit familiar. An index that's to do with how you actually store the data and reorganize the data on disk, that's also known as a clustered index. So that's kind of the approach. The way I see it, you've got Delta and Z ordering as a clustered index for changing how you store data on disk. Hyperspace. So this new thing that Microsoft have open sourced, and it is completely open source. You can use it on your own Spark system. You can use it on Databricks. You can use it in Synapse. You can use it in HD Insight, a Cloud Era distribution. Wherever you are running Spark, you can import this library, as long as you're using 2.4 and not 3.0 yet. But still. And what it does is it kind of does a non-clustered index. So we're saying, I want to create an index across this data frame, this particular location of data. It'll create a separate data store, which is logically reorganized and optimized for the columns you're indexing on. And you can include some covering columns. So as in SQL Server, if we're creating a non-clustered index with included columns, what that means is we've got our B-tree style index thing, and then we've got some columns in there. And if someone queries that table on that index predicate, it can go to that non-clustered index, work out what data it needs, and then go, oh, actually, I've already got the data here. I don't need to go to my full data set to bring that data back. And it's the same idea that's been applied here in Hyperspace. So we can say, I want to create an index on this data frame. I want to index based on these columns. This is what I want to sort and optimize my data on. And I want to include the original values from this list of columns. So it creates a copy of that data that pre-organized and optimized for a certain thing, but tied back to my original one. So I can refresh those indexes, resync them, and then work with those. And then certain queries, and they just need data that's included in one of the indexes, and they're using a search predicate on one of these indexes, they'll go straight to that particular index, not to the master data set. That's kind of the idea. That's what we're trying to get working. So let's have a bit of a look. So first things first, there's a blog page. They announced it way back when the Spark and AI Summit, I believe. And they were talking about how this works, and it is this hyperspace thing. I think they're on 0.2 now, but essentially it is an open source thing. You can go on GitHub, you can see the code behind it, you can work with it wherever you want. Load of stuff. Yes, it makes things go faster. Happy days. I'll put the link down below. You can go and have a look through that. It's all good. The main thing that links to is this. You've got a quick start guide that tells you basically how to get started. Now, the assumption in here is that you're kind of working on a non-Microsoft system. It's kind of, this is the vanilla approach, is the one that's been put out by default. So it tells you, well, this is how you build the Maven dependency. This is how you pull it down, do an SPT build the jar associated to Spark cluster. Essentially, there's a lot of preamble at the start, which actually makes it sound fairly complicated, which is just about installing the library on your cluster. Now, the good news, you don't need to do that with Synapse. So when Azure Synapse Analytics in their Spark Pools, this is installed by default. So do not worry about any of that preamble. You've already got it. You can just start using Hyperspace without worrying about anything. So that's kind of useful. There's then a load of preamble, the setting up a sample data frame, and then this is where we get to the meat. It starts talking about this Hyperspace library. So this is the crux of it. This is the new library you can import into your own Spark cluster, again, installed by default in Synapse, and then you can start doing Synapse commands. And at that point, we'll switch over. So this is good documentation to kind of have a look through, kind of understand what the different commands are. I'll show you how it actually works. There is a full worked example, so if you want to step through that, but that is in Scala. And me, Python boy, I'm over in Python, and we can go and have a look at the Python version of it. So I've got 2 bits of Synapse open. I've got one which is creating the index. I'm just going to make sure those sessions are still alive. So one creating the index, and then one testing and saying, am I actually using that index? Essentially, again, SQL Server parlance, has my execution plan been updated to use the index, not the original data set? We can do the same kind of thing. So from Hyperspace, import star. So again, I could actually just import Hyperspace and be kind of a little bit neater by just bringing in the whole Hyperspace library so I can start working with it. Okay, make a new thing called HS. And that's just essentially an alias to my instance of Hyperspace. Create a new Hyperspace object in my current Spark version. So whenever you see that Spark and use it in, data frame equals spark.read, all that kind of stuff, that's just referring to your current Spark session. Managed Spark clusters like Synapse, like Databricks, they do that for you. If you're building your own thing, you'll be well used to saying Spark equals new session, blah, blah, blah. So, okay, I've got my current session, I'm wrapping Hyperspace around it, and I'm aliasing it as HS. So that worked, that is happy. I'm then bringing in a data set, so I've got a data frame saying spark.read.parquet, go and get that data. Because I need to give it that reference. I need to say, you know what, I want an index on this bit of data. And the way in Spark we say this bit of data is through a data frame. So it's expecting a data frame reference to know what to put the index on top of. So I'm saying, okay, my data frame is equal spark.read.parquet. It's just, this is the folder. We can go and have a look. So data set. My root folder that's associated to Synapse, base, NYC Parquet. Got loads of different years in here. Inside my years, I've got some months, I've got some data, got loads of days. So it's kind of a heavily partitioned thing. If someone's querying this data and they're querying on the year, month, or day, then they're going to use partition elimination. They're going to go straight to my data. That's going to be fairly efficient. If someone's querying this on something that's not one of those columns, then suddenly they're going to have to read everything, all of those different partition files, and bring that data back. I think there's like 84 million or so rows in there, which not huge, but could cause some issues. So I want to be able to query it properly. I want to be able to go and do something, and that's where this comes in. So HS, that's my Hyperspace instance that we referenced at the top, we created, saying create index. So I'm making a new index, making a new non-clustered index, and I'm passing in that data frame. So I'm saying take that thing, everything that is encapsulated inside that data frame reference, pass it into this create index statement. And then what do I want? Pass it an index config that tells it a little bit about the index I'm trying to create. So I need 3 things. 1, the name of my index. Yes, I'm fully aware I've spelled that wrong, but I've just baked everything in now. I can't be bothered changing it. So my rate W total is the name of my index. The list of columns that I want to index on. So again, this is a descending list. So the first one will be fairly optimized, gets less and less efficient as you go down. You don't want too many columns in there, the same as any other kind of index. So in this case, I'm just optimizing for a rate code. So rate code is one of the attributes in my data set, and I'm assuming there's a particular issue, someone always wants to go, just tell me the sum per rate amount. And I don't want to have to create that as a separate table. I want it linked back to my main data. And so we need to get that tied in as a separate index. So creating a new index, indexing on the rate code, and I'm including the total amount. So total amount, it's not indexed by it. I can't search directly on total amount. But if I bring back rate code, I can reference the total amount directly without having to go back to the main data set. So essentially, I'm making a covering index that allows me to query on that and aggregate based on that, and that's going to be super efficient. So that's what we're trying to do. We're trying to say, I want to go and create an index with that details. I may have created that index before. We will see if it errors, but that should be okay. And then that goes off and it creates a separate data set inside my Spark instance. So depending on where you're running this will depend on where it actually creates it. In this case, because I'm running it in Synapse, there's a load of baked in Synapse folders that's going to create inside my lake for me. So while it's doing that, we can go and take a look in the lake and have a look at what it's doing there. So under root, right back, I've got that Synapse folder. So that's not something I created. That's created automatically by Synapse when you associate it to a data lake stored Gen 2 as its root thing. So it's created Synapse. Inside there, we can see workspaces. You can see the name of my workspace because you can have several different Synapse workspaces all sharing a lake. It's inside my warehouse it's going to be. And then I can see that's a user database. That's a database I've created to do some stuff. And then it's created this new indexes folder. So I've now got that folder that I can go and have a look at. And then each index that I create, so you can see I've got my dodgily named one. Every time I create an index, it has a separate folder in here. So index names have to be unique, but that's no surprise. And then inside there, it'll have a log. Just here's all the different changes. This is when I've refreshed it. It's working a little bit like Delta in that it's got that transaction log of all the changes I've made to my index. And then it's got my actual data. So this is just a separate Parquet store, which describes the data I've got inside there. So that's what it's doing. It's essentially just making a separate cut down reference data set that's associated to my original data set that will kind of divert. So if I query and say, go and query my main data set, and actually it can look and go, oh, by the way, there's an index that's a much smaller file that's going to be a lot easier for you to find your data. It'll then divert that query and query this data set instead. That's the whole point. But be aware, you are creating a separate copy of your data. So if you're trying to do this on massive, huge data sets, you might create other massive, huge data sets. So there is overhead to it. Okay, so that succeeded. That went off. It created my new index. And I've got this little, you can do HS. So again, my Hyperspace reference indexes. I can display that as a data frame. I can say, what indexes do I have? And we saw those 3 folders. So I'm expecting 3 indexes in here. There we go. So I've got my new index, my rate total. Oh, is the other one not a real index? Maybe not. But I can see what those indexes are. What were my index columns? What were my included columns? I can see the number of buckets. So it's automatically done that 200 default partitions, which is a bit weird. But that's probably just sort of how I had the data frame created. And I can see some details around it. All the way over, I can see where that index lives. So that's telling me, if I expanded that, it's telling me where that lives inside the lake. So again, we can go and get some details. So if you're working in just, I can go and use that without actually having a data frame. I can just open a Spark instance, say, what indexes do I have? And that'll give me my nice little array. Kind of the same, again, SQL Server. If I do select star from sys.indexes, that's kind of looking at the same thing. What's going on inside there? So that's created an index. So if I query this particular lake location, and I'm querying when I've got some kind of predicate or grouping or something based on the rate code, and I'm including the total amount, I've created an index to specialize for that. So over on the other side, I've got another Spark session. So I've got that in here. So I've got my data frame kind of ready to go and read that particular bit of Parquet. I just refresh that to go back to it. And then I'm doing this. I'm saying, well, I want to filter it to a specific rate code. So I'm passing in a search predicate that matches the index column that I've created my index based on. And I'm saying, and I just want to limit it to those 2 columns. All I care about is the 2 columns I've particularly got in mind. So we can actually sort of line that up and say, okay, filter my data frame down, and then we can run an explain and say what's going to go on inside there. And I've definitely noticed something a little bit interesting, which we'll see if this has got to, and we'll come to that at the end. Okay, so I filter my data frame. I can see in my data frame it's doing a Parquet file scan. It's going to filter it. It's going to do a project. That's all it's doing. And then I've got a different kind of explain. So I've got a Hyperspace explain. So rather than hooking into the pure vanilla Spark dataframe.explain function, I can now do a different explain saying, hey, Hyperspace, explain this. I've got a data frame, passing my data frame into it. I'm saying I want it to be verbose, I want to see what's going on. And then say, what are you going to do with this information I've given you? And this is whether or not I've got Hyperspace turned on. This will tell me, would you use Hyperspace? So it's saying, my plan with indexes is this, my plan without indexes is this, the index use. So I can see it is indeed going and using my index. Now the plan hasn't actually changed. It's just deciding whether or not it's going to go, well, the plan's changed a little bit. It's still going through the same steps, but you can see rather than doing a file scan on the Parquet and bringing back all the columns and then filtering it down, it's doing a file scan on Parquet that just has those 2 columns in. So it's getting my cut down, my slimmer data set, reading less data from disk, so it's going to be faster. So it's telling me what it's going to do based on that. Now, weirdly, despite the fact it's going to a much smaller file and it will be faster, the physical operator stats keep telling me nothing's happening, which I find a bit weird. That might just be how I've set up that index. So basically, I can do an explain plan that will kind of just say this is what's going to happen. I can say, actually, if I turned on Hyperspace, what would happen? So we can go in. I can do some other stuff. I can boil it down. Then I've got this command. So hyperspace.enable in my Spark session. So again, by default, my Hyperspace was not enabled. I created this index. If I wanted to use that index, I have to turn this Hyperspace enabled on. So I'm going to enable Hyperspace on there. And then I think if I still, even though I've got Hyperspace enabled, I'm not sure it's going to actually tell me that it's going to use it when I look at my plan. I think I'll still see the original one in there. Yeah, so it still thinks it's going to go off and use that full set, even though we now know when we're using it, when we look at this going, what would you do if you had indexes? And it's like, well, I'm not going to select from everything. So the explain isn't fully hooked up, which is a little bit unfortunate, but still. Then I can run my go and display, and that's going to go off, and that's going to read from my index column and be faster than reading from my full data set. So it's kind of useful, it's kind of nice, it's going off, it's doing some smart things. However, the weird, interesting thing that I found here, so I was basically just running this demo a few times, going, okay, try it again, and I noticed it stopped using Hyperspace, which is weird. So if I just run everything again, I'm going to run the entire thing from start to finish, and we'll see if this does the same thing that I was seeing earlier. So it's re-importing Hyperspace, it's re-getting that Parquet from that location, it's doing a filter, it's doing the explain, and then when we look at this Hyperspace explain, we might see the same thing I've been seeing. Yeah. Okay, so now it's saying, oh, I'm not going to change anything that I was doing, because it's already in memory. That's weird. So for me, certainly, if I was seeing that, I would expect to have said data frame.cache. I'd expect I've told it to say, hey, cache this in memory. Next time I do an explain plan, it'll go, yeah, I'm not going to go and read from disk. I'll get it from my cached in memory one. Now, this is doing it regardless, even though I've not said go and cache it. So it actually looks like the current implementation of the Spark Pools inside Synapse is automatically caching data frames for me, which is cool. But makes it really hard to work out if it's going to hit an index because it's automatically cached it. So in terms of when planning out this, I kept having to stop my session, restart my session, have a look and see if it was actually using the index, and then go, cool, it is, and then I'd rerun it, and it'd disappear. But that's very interesting, because essentially so the Hyperspace index will be very, very useful if you've got jobs that are spinning up a new session, going off trying to read the data, going, oh, that's big, going off and getting it from, again, my indexed version of it, and then shutting down. And then next time they start up, they don't have a cache because it's a new session, they're going to have to go back and use that index. Whereas if you're spinning up some data and then you're doing lots of things with that same data frame in the same session context, actually Hyperspace isn't going to be useful, because after the first time we brought it into memory, it's cached. So I'm not having to go back and read that index from disk. So a bit weird, but certainly super useful getting an idea of what's going on there. There's lots of applications where you might think, I've got like 10 different ways people might query this data set. I don't want to keep the entire data set because there's tons and tons of columns. So actually, let's just create little different subsets with different indexing columns to keep my users happy. Kind of makes sense. I'm still not entirely sold that I'm going to use it that much, honestly, because it is a little bit of overhead and turning it on for everything and having to maintain those different indexes, the different redundancy of having that extra set of data kept. don't yet know if it's valuable enough to actually make me do that. The other thing is keeping them up to date. So we have a few commands. So I have these ones down in. So if I wanted to get rid of that index, I could say I want to go and delete that index. I can run that, and that's going to go and soft delete the index. So it's going to mark it as inactive. So I think if I run this again, I should see that same index in there, but I think it had an active flag. So we can go and say, what indexes are that? Yeah, so I can still see that rate total, but there we go. I've got this deleted state in my particular index. So that's not being used, but it's still there. I've not deleted the data. And it's only when I go and do this vacuum, which again, confusing terminology with delta and all that, kind of makes sense. It's doing the same thing. That's going to go through and physically delete that data, so I no longer have it. So that kind of makes sense. It's just index management. That's cool. I've no longer got it. The slight pain point is if I want that index to be updated, I've got this refresh index, and then I'd need to call it, let's call it new index. So that's going to take an existing index, go back to the data frame, rework out what that index should look like. Now, again, that's a manual job by the looks of it. So if I'm updating data that I know I've got indexes on, I need to remember to run refresh index on each of the different indexes that exist on that data frame. So that's additional overhead on my side. Now, again, this is version 0.2 of Hyperspace. I'm sure there's a lot of, again, quality of life, implementation features, all that kind of stuff that are going to roll into it before we get to V1. But it's an interesting idea. So certainly lots of things you could do with it. Certainly there's definite performance scenarios where this is going to really, really, really help people out. It's just, will it solve every performance thing? No. The same as Z ordering won't solve every different performance problem. So definitely an interesting idea. So that's Hyperspace, again, baked into Azure Synapse Analytics by default. Discovered that Azure Synapse Analytics seems to be caching automatically whenever I bring a data frame into context and run an action on it, which is, again, surprising and weird, but seems to be the way it's working. Kind of makes sense given we've got the idea of Spark Pools and we don't have a shared cluster. So I'm not going to push other things out of cache because I've just got the one session that I'm working on. Kind of makes sense. It'd do some caching of its own. But yeah, definitely an interesting idea, this whole Hyperspace thing. So, as usual, don't forget to like and subscribe if that is a useful video to you. Let me know in the comments if you use Hyperspace, if you're going to start using Hyperspace, what you kind of think of how it works and how it fits in. And again, we'll see you next time for some more Spark and or Synapse fun times. So, cheers.